Okay, so I'm going to go over this problem where we're asked to find the absolute max and the absolute min. Now, one thing so let's again start off first. We'll take the partials. So this is our area, our region D. So in this region, we need to find what is the maximum, what is the minimum value of this function here. Okay, so we start off, we find the partials. All right, and now we set each of these equal to 0. All right, and when we do that, we get x equals 1, y equals to 0. Okay. All right, so that is going to be one of our points of interest, right? Somewhere right here. So we plug it into our function here, and we get what? 1 plus 1 is 2. Excuse me. 1, and then minus 2, we get negative 1. Okay, so that's one point on the surface, on the solid there that we have the value for. So now we need to check what is happening on the boundaries, right? And by the boundaries, I don't just mean what is happening at the endpoints of the boundaries, right? We can check those, right? We can say, all right, let's find out what happens at 0, 2, 0, negative 2, and 2, 0. Right? Each of those we see, okay, so we do this, 0, 2, we get 4, 4, 2, 2, we get 0. Okay, and again, those are all candidates to determine if these are, in fact, absolute max or absolute min. But we're not done here, right? We need to know what is happening along this boundary here. Right? And the way we do that is by, well, figuring out the behavior, right, there, right? Y is equal to negative x plus 2. So what we need to do next is we say, all right, on L1, I need to find out what is happening there. So the way I do that is I plug in negative x plus 2 for my y. So we get x squared plus negative x plus 2 squared minus 2x. All right, so I'll expand, combine like terms, and in the end what I should get is 2x squared minus 6x plus 4. All right. Okay, so now we see it has a parabola, right, open upwards. So in between our values where x comes between 0 and 2, those are the values of x, right, we're going to have a minimum at the vertex, right? So let's see where that vertex finds, right? You can take the derivative, or if you remember from algebra, the vertex occurs at negative b over 2a. So that means negative b is 6 over 2a. So that occurs at 3/2, right? This is our vertex. All right, and that is well within the range of 0 and 2. So now we have an additional point to find, right? If x is 3/2, right, y is going to be 1/2, right? Negative 3/2 plus 2. All right, and plugging that in. Simplifying here, we get negative 1/2. All right. Okay. Right. So again, we can add this to our list of possible absolute max and mins. We can see that it won't be, but we still need to check, right? We need to make sure that we are certain that we are in fact finding the absolute max and min. So let's kind of take our next kind of boundary here, L2, right? X is 0. All right, so when x is 0, we have 0, and we simply get y squared, right? And again, that's a parabola, right, where the vertex is at the origin. So in this case, we'll check X is 0, so the vertex, the y coordinate would be y, and in this case we get 0. All right, so f of 0, 0 is equal to 0. So I'll add that to my growing list here of possible absolute max or min. All right, and then we move on to the third boundary. Y is equal to x minus 2. So on L3, we get y is equal to x minus 2. So again, we just replace the y with the x minus 2 squared minus 2x. All right, and then again, simplify here. Combine like terms, we get 2x squared minus 6x plus 4. All right. Okay, and looks like the same quadratic as before. So we have a vertex to occur again at 3/2. And in this case, we get f of 3/2 minus 1/2. Right? And then plugging that in, we get the value of negative 1/2. So our next possible point is f of 3/2 negative 1/2. That's equal to negative 1/2. Okay, so we see here all our possible options for absolute max and min. And we can see here, oh, and of course, I forgot to add this one. Let's just write it here. And then now from all these points, we choose the largest. So choosing the largest here. These are our max. And the smallest, that is our min. All right, so that would be the max and the min, and they occur here, 0, 2. And the min occurs here. Okay, again, we do have to make sure that we check those boundaries. Now let me show you what we just found. Okay, give me 1 second here. Okay. All right. So what we see here is right now we see the projection there onto the XY plane of the surface itself, and also you see the boundary, and you see some other points there, the critical point there, A, and then those boundary points, right? So what we are doing here is, if I kind of move it here so we could see what's going on here, right? You could see the boundary there on the XY plane, right? And then you could see kind of all along the boundary, and you could see that is on this paraboloid, those lines that are going along the surface. Here, those are the values of the function f of the multivariable function f of xy. All right, so that's how we have to make sure that we do check. You see here are the maximums, right, and the minimums, right? But we do have to make sure that we check within that boundary what is happening on the surface, all right, so that we can be certain that we have in fact found the absolute max and min. Okay, so again here we'll have XY plane, right, the projection, and then we could see what that boundary is doing on the surface.